My name is Amy Williams. I have a PhD in geology, but I'm actually an astrobiologist, which means that I'm interested in searching for life beyond Earth and the types of instruments and techniques that we can use to accomplish that. So Curiosity is in Gale Crater, which is a 150-kilometer wide impact crater on the surface of Mars. Yeah, the SAM instrument is one of several instruments that's on board the Curiosity rover. SAM stands for Sample Analysis at Mars, and it's not a very descriptive name because it's actually several instruments wrapped up in one. At the time it was built, I think it was the most complex single instrument that had been sent to Mars. And the SAM instrument, one of its capabilities is to detect organic carbon. And you may know that organic carbon makes up all life as we know it. And so searching for organic carbon on other worlds can tell you maybe if there was life, but more likely than not, what it's going to tell you about is whether the building blocks for life were ever present or are present now on Mars. And so that is kind of what we've been focused on using the SAM instrument on Curiosity. Organic carbon being the building block for life as we know it is going to be exciting to detect it at all on Mars. And we have detected it several times in different locations as we've been traversing through Gale Crater, where Curiosity is currently exploring. And seeing small molecules tells you about sort of the building blocks for life, the presence of this material, and the fact that it can survive on the Martian surface right now, which is very inhospitable, is really exciting. But when you think about really small molecules, they tell you less about whether there could have been life on Mars. You really need to get to larger and more complex molecules that can help you understand that question. And that's what this paper was about, detecting the largest molecules we've seen to date on the surface of Mars. And when we talk about large, you might have a certain idea in your head of what that is. In this case, it is, if you picture how small a carbon atom is going to be, it is a couple of molecules that are 10 to 12 carbon atoms long. So that is still quite small in the grand scheme of the universe. But for our detections on Mars, that's the biggest thing we've ever seen. And that is exciting because that means that we are finally getting into the realm of detection where you might see something that could have been made by life, something that's larger and more complex. You're sort of in the right size range of organic molecules in order to kind of make that assessment. So even though these molecules that we saw don't tell us whether or not there was life on Mars, they tell us that we are capable of detecting the types of molecules that can help us answer that question. Mars sample return, and I've said this so many times, it is going to be revolutionary for not just for planetary science, but for science and I think the humanities, people's perception of themselves and life in the universe, because Mars is like I've described it before. It's so Earth-like in the past and it's so alien now. And having rocks that come from a time when Mars was habitable actually gives us an insight into Mars sort of in its infancy, when it had the planet had the capacity to support life as we know it. So bringing these samples back, you can look for evidence of that life, but you can also do really fundamental things like find out when was there water flowing on Mars. We know there was a ton of water in the ancient past, but we don't know with certainty when, and we don't know when that water dried up. And so bringing rocks back, that's really the only way for us to answer this huge suite of questions about Mars's evolution, and that impacts how Earth has evolved, Venus and Mercury, like all the rocky worlds. But as an astrobiologist, my keen desire is to understand the question of whether we're alone in the universe. And having these samples would actually give you a really great insight into one of the best possible places we can look for evidence of life. Is it there? What can we learn about Mars that is, we just can't miniaturize every instrument possible and send it to Mars. Bringing those samples back even though it is pricey in the beginning, that is going to be the gift that keeps on giving. And we're talking about just generations of science that can be done on these rather small but extremely precious samples. As an astrobiologist and a scientist, I know I need to be really pragmatic, and I need to be led by the facts. And right now, Earth life is our only data point. I think that the search is super important. I don't think we are alone in the universe. I think that there is life, and I hope in my generation that I get to see that knowledge finally brought to humanity for us to really start to frame it as how unique and precious Earth life is, because I don't think life in the universe is super abundant, but also I do not think that we're alone. And one of my favorite quotes, actually from Carl Sagan, kind of sums it up. He said in his book Contact, space is an awfully big place, and if it's just us, it seems like an awful waste of space. I think that I'm an astrobiologist because I've always wanted to learn about nature and about the Earth, and that has expanded now into the space beyond Earth. I had a really supportive family that helped me pursue science as a passion and then as a profession. I remember we would go out and watch meteor showers as a family, and we'd lay in the back of the pickup truck and watch these meteor showers. And I remember thinking, I wonder if out there somewhere there is another little girl looking out into her space and wondering if there's someone else looking back. And I remember that very fondly as time with family, time learning, and also cultivating sort of this passion for science and exploration that I try to move forward with today and instill in my students and in my kid as well.